Hi, in this video we'll be showing you how to complete Hands-on 5 entering input data for the reconstruction of the base year. Please be advised that in this video this will be the practical matters of how to solve the hands-on. However, you must read the PDF document in order to understand how the construction is being done. So, firstly we'll be focusing on adding data for the base year of reconstruction. Essentially, one thing to understand is that input data are usually entered in two phases. The first one involves reconstructing the base year, and the second one involves scenario data. This will be further explored in Hands-on 7. In this case, what we're meant to do in order to complete this hands-on is take the demo case as we have it, which was demo MAED 1, the one that we've been working on, and create a copy of it, renaming it to MAED 2. The years will be different for this one. It will be from 2030, 2035 to 2040, so only these 3 years, with 2030 acting as our base year. Please be advised that in the creation of your country model, we recommend using data from 2018. However, if you have any more up-to-date data, you can use the more recent data versions. So, this is what we need to end up with. The first step is to come back to our MAED model. Go to Manage Case Studies, create a copy of demo MAED 1. Once we've created the copy, we're going to go into the copy itself and rename this to demo MAED 2. Please ensure to click the Save button every time you save something. And over here, we're going to get rid of all these years and we're going to paste the years that we're interested in. And click the Save button. So let's compare this with what we have over here. It looks to be exactly the same. So at this point, we've created another case study, demo MAED 2, and this is the one which we will be working on. So once we've done this, what we need to do is add data for the base year reconstruction. So here specifically, we're going to add the socioeconomic data. The data has been presented in the picture over here, and we must ensure that our data matches the same data. So what we're going to do is we're just going to zoom in into this to get better visibility. So here we're talking about the socioeconomic data. So let's go into our case study and go towards socioeconomic data. Here we can see that there is numbers that need to be filled in. The gray boxes again are the ones that fill in themselves, and the white ones is the ones where we fill in the data. So what we're going to do is go back, and we're going to see that for population the number is 19.5. So we're going to go back into the model, and here we're going to input 19.5. And then we're going to save the data. Then we're going to go back, and we're going to see that the urban population percentage is 41.5, and the person urban household cap is 6. And so we're going to go back, and we're going to put in 41.5 and 6. Click the Save button. We can see that already the model is beginning to do the calculations based on the numbers that we're feeding into it. The person/rural household cap is 7, so we're going to enter these over here. Click the Save button. Going to go back, and we're going to see that the potential labor force is 49% and participating labor force is 40%. So we're going to put 49 over here and 40 over here, and we're going to click the Save button. And then lastly, population in cities with public transport is 22%. So we will enter the number over here and click on Save. Now we've entered the numbers for 2030. We can see that there's numbers that can be entered for the additional years. In this instance, the numbers over here correspond to 0. So what we're going to do is we're going to enter 0 for them. So let's say over here, starting with the population growth rate, we're going to put it as 0, and everything else is also going to equal to 0. So 0, 0, 0, 0. And we're going to save the data. So the data has been saved successfully. Let's save it once more just in case. And now coming back to the hands-on, we're going to need to input also the GDP data, which is shown on the next page. So here we need to click on GDP. Going back, we can see what is the defined numbers that we input. So the GDP in US dollar millions is 1,230. So this is the first number that we enter, 1230, and we click on save. Then in terms of the sectors, agriculture, construction and mining are 10% respectively. So 10, 10, 10. Manufacturing is 38.37398. So 38.37398. That was a mistake done over here. So let's change this to 3. And the services sector is 20%. Over here, the numbers are somewhat different, so we need to ensure that we change these numbers as well. So GDP growth rate is 7% in 2035, and in 2040 it's 6%. So 7 and 6. Click on save. Agriculture remains at 10% for all the years. So 10 and 10. Construction goes down to 2.1 in 2035, then to 2%. 2.1, 2. Mining is at 5.3% in 2035 and 5.2 in the year afterwards. Click on save. Manufacturing goes down to 15% and then increases to 17%. And services goes up to 51% and then increases to 53%. Click on save. Then what we need to check is the numbers over here below. So if we scroll down over here, we can see that these numbers need to be input in. So for commercial and tourism, 2030 is 30%, then 28, then 25. Click on save. For public administration, it's 10% for all the years. Click on save. For finance and business, it's 5%, then 10%, then 15%. So 5%, 10%, then 15%. And we click on save. So we've successfully entered the data, and now what we have to do is click the calculate button from the main menu, which is this one. This implies that the numbers have been saved and this is all good to go. So if we go back into the socioeconomic data, we go into GDP, we can see that all of the numbers have been saved respectively. Now, the third activity that we need to deal with is visualizing the socioeconomic intermediate results. So even with this much data, this can already be done. We've already clicked the calculate button, so now we need to look at the results. So we're going to go into results, GDP, and GDP formation by sector. Here we can see the figures that the model has calculated. We can compare them to the figures that have been shown over here, and we will see that the figures are the same, more or less. There is some differences in terms of decimal points, but that is not to worry about. As long as the figures match in terms of their accuracy in more or less numbers, then we're good to go. We can see that this is in fact the case. Now, the next step is to calculate the MAED input data for the base year reconstruction. The instructions over here on the hands-on explain to you how these are calculated with the formulas given directly for ease. You need to ensure that you understand how these calculations are done in order to understand how the model works with them. There has been a template designed to make these calculations easier for you, which can be accessed via the following link. So if we click on this, it's going to take us to Zenodo, and we'll see MAED results reconstruction base here. We download this. Once this has downloaded, we open this file. We enable editing if needed, and we can see that there is many different sheets on this. The first one that we're going to come into is this one, which is the ing agar row data. So if we go back to the hands-on exercise, we can see over here that once we've downloaded it, then there's the explanation given of what each of the main 4 sheets that we're concerned with explain. So in this case, we have ing agar row data, whereas we put the data. Here's where the reconstruction takes place. Here's the inputs that we're going to use into the model, and here are the outputs. So what we're going to do over here is begin with the raw data collection. Description of this is given over here, and the data is given over here. We need to ensure that this data matches the one that we input into the template. So in this case, in the raw data template, here are the numbers over here and the numbers specified over here. These numbers are in fact the same. This has been done to make things easier for you for the initial stages. Then what we need to do is calculate MAED input data for the base year. If we scroll down over here, there's been a definition given as well of how this can be done and how we need to fill in the various tables within the data calculation. So for example, the useful energy demands table. If we come over here, we'll see that this has already been filled in because there is formulas put into place from the model itself. What we can do is just simply check the numbers and see that they match. They do in fact. The rest of them need to be calculated by you in order to ensure that they match. And in the end, when we want to end up with these tables, all of them being completed respectively. Please ensure that you follow these steps carefully and you understand the methodology behind the calculations in order to understand how the model comprehends these numbers. The next thing that we need to do is input the calculated and collected data into MAED. For this, we need to go onto this sheet, and here we can see that right now it's blank, however formulas have been set up. Before revealing the numbers of what the formulas have calculated, please just calculate yourself these numbers in order to understand how things work. Once these numbers have been calculated and the table is full, we need to input this data into the MAED software. So what we need to do is go into the MAED software to the energy intensities for industry page and add the data that we've calculated per each end use. One thing to note is of course the energy units. So the first place that we're going to is electromotive power. We're going to close this, going to go into energy intensities, and we're going to look into the industry for electromotive power. Now if we go back over here, what we're going to be looking for in this instance is going to be the electromotive power, and the number for this for the base year 2030 is 0.260163. So going back into the model, I'm going to put the number as 0.260163. And we're going to click on save. So once we've inputted this number, the next thing we want to add is the electricity specific use. When we click on this, we see that agriculture is in fact not represented under this. This you will remember from a previous hands-on on how to do. In which case we need to go into general information and we need to ensure that specific electricity use and thermal use are both selected, and we click on save. Then we go back into industries, back over here, and we can see that farming is present now. So the number over here is 0.105691. So 0.105691. click on save. Then we need to go back and we need to finally add the number for the thermal use. We go back into our spreadsheet. This is 0.543089. Click on save. Then we click on calculate. The reason we click on calculate so that we can see the values of useful energy used to produce the motive power. Now what we need to do is input the penetration of energy forms into MAED for 2030 only. So we go back into energy intensities, industry, penetration of energy forms. We can see that this table is now empty. So we come over here and here is the figures that we have. So for traditional fuels it's 10.77844. 10.77844. For modern biomass it's 49.1018. For electricity it's 16.46707. And then for solar thermals it's 7.48503. And for fossil fuels it's 16.16766. Click on save. Then we move into efficiencies for thermal use percentages. So we come over here as instructed on the hands-on, and we need to input this data, which is over here. For traditional fuels is 60, modern biomass 80, fossil fuels 90. 60, 80, 90. Then we click on save. We go back onto the hands-on, and at this point the results from MAED should be compared to the recorded data to confirm the accuracy of the reconstruction year. Go over here, click on calculate, and then on the results tab we go into industry energy demand access to total final energy demand. In comparing the numbers, we need to look at the fourth sheet over here and ensure that the numbers are the same. So for agriculture in traditional fuel 0.0014, which is 137 over here, so it's a rounded number. Modern biomass 468, which over here is 47, again a rounded number. Electricity is 27, yep, corresponds. Solar thermal is 57, corresponds. Fossil fuels is 14, again when rounded corresponds. And motor fuels is 37, when rounded corresponds. So the numbers all correspond, which brings us back to the hands-on. When you build your real country case study, you will have to repeat the same exact steps for the agriculture sector to the construction of the base year and the mining sector. And the manufacturing sector is similar, but as in its previous hands-on, the thermal use is split into high temperature, medium temperature, and low temperature. Thank you for watching this video. I hope this was useful to you.